Hi everyone. Notes 6.6 are on problem solving using sinusoidal models. Question number 1 says that a group of students is tracking a friend Ben who is riding a Ferris wheel. They know that Ben reaches the maximum height of 11 meters at 10 seconds and then reaches the minimum height of 1 meter at 55 seconds. So the first thing it asks us to do is to develop the equation of a sinusoidal function that models Ben's height above the ground. Now remember, we can have infinite possible equations, so we're just going to find one possible equation that's going to work, okay? So I just want to draw a quick sketch of what's happening here. So when I draw this quick sketch, we're looking at time, and we are looking at the height. Okay, and it says that he reaches his maximum height at 10 seconds, okay, so we know, and the maximum height is 11, and then we also know that he reaches his minimum height at 55 seconds, and that minimum height is 1 meter. Okay, which means that our graph will end up looking like this. So looking at this, it appears that it will be a sinusoidal function, but more specifically, we might want to use the cosine function because it starts right here at its maximum. Okay, so we need some information. The first thing that we need is the equation of the axis. So to find the equation of the axis, remember, it's just the halfway point. So to find it, we just add 11 and 1 together and divide it by 2. So we get 12 divided by 2, or 6. So that, remember, is going to be the C value. Okay? Then let's find the amplitude. So to find the amplitude, we are going to subtract the 2. So we'll do 11 minus 1, divide that by 2. So I get 10 over 2, or 5. So 5 is our amplitude right here. Okay, now to find the K value, we need to know the period. And our period right here, we know that it will take, this is supposed to say 10 seconds. I'm going to erase the S because the S is right here. We know that it will take 45 seconds to complete half a cycle, which means that it will take a total of 90 seconds to complete a full cycle. And remember, our period is always going to be equal to 360 over K, which means that K equals 360 over the period, or 360 over 90. So our K value is 4, which means it was compressed with a scale factor of 4, which should make sense because a normal cycle is 360 degrees. Okay, and then the last thing that I need to know is what my phase shift is. So for my phase shift, I can see that it moved 10 units to the right because my maximum is not occurring at 0, it's occurring at 10. So that means that D equals 10. With all that information, I can put it all together and I can say that the equation of my function is going to be y equals 5 times the cosine of 4 times x minus 10 plus our equation of our axis, which is 6. Okay? All right, so then, now that I've done that, question B asks us to determine Ben's height above the ground at 78 seconds. So I'm going to I'm going to plug in 78 for our x value right here. So I'm going to say y equals 5 times the cosine of 4 times 78 minus 10 plus 6. So I'm going to say y equals 5 times the cosine of 4 times 68 plus 6, or just say y equals 5 times the cosine of 272 plus 6. And then when I type that into my calculator, I will get approximately. So question C says to determine how long it will take for Ben to first reach a height of 6 meters. I want to do this algebraically, and I also want to do this logically. Okay, so 6 meters is the equation of our axis, which means that that's the halfway point. Okay, and the halfway point right here, the 6 meters, will always occur a quarter of the way through the cycle. So if the full cycle is 90, I need to figure out what a quarter of 90 is, and then add that on to the 10 for my horizontal shift. Or I could take 45 and divide that by 2. Either way, I'll get the same answer. So 90, divide that by 4. I get 22.5 seconds, but that's added on to, so this right here would be 22.5 seconds. So altogether, this would be 32.5 seconds. So it will occur at 32.5 seconds. But let's just double check to see if this is correct algebraically. So I'm going to fill in 6 for y this time. And it's going to be 6 equals 5 times the cosine of 4 times x minus 10 plus 6. And then I'm going to get rid of the 6's on both sides. So I get 0 equals 5 times the cosine of 4 times x minus 10. Okay, and then I'm going to get rid of the 5 by dividing everything by 5. So I get 0 equals the cosine of 4 times x minus 10. Now the next part is a little bit different. We're going to let u equal 4 times x minus 10. And the reason why I'm going to do that is because now my equation is going to say 0 equals the cosine of u, which is a lot easier to deal with than saying 0 equals the cosine of 4x minus 10. Once I do that, I'm going to solve for u by doing the inverse cosine. So u is equal to the inverse cosine of 0. Okay, and so we need to figure out when the cosine is going to be 0, and we know that cosine will be 0 right up here at 90 degrees because the x value is 0. So u would have to be 90 degrees. It could also be 270, but it says to first reach a height of 6 meters, so we only need the first value. All right, well, if that's what u is, okay, and if u is equal to 4x minus 10, I'm going to say right here, 90 equals 4 times x minus 10. Then I'm going to divide both sides by 4, and I get 22.5 equals x minus 10. Add the 10 to both sides, and that's how we get 32.5 equals x. So it will take him 32.5 seconds to first reach a height of 6 meters. Okay, so for number 2, it says the top of a flagpole sways back and forth in high winds. The top sways 10 centimeters to the right and 10 centimeters to the left of its resting position and moves back and forth 240 times every minute. At time equals 0, the pole was momentarily at its resting position. Then it starts moving to the right. So if you look right here, we'll just do a quick sketch of the graph. We know that we're looking at time in terms of seconds, okay? And we'll do that because it's 240 times every minute. It's easier to look at it in seconds because then it's 240 times every 60 seconds, okay? And then we'll also look at the distance the flagpole sways, okay? So, or the horizontal displacement of the flagpole, okay? And that's in centimeters. And it sways 10 centimeters to the right and 10 centimeters to the left. So right here, what we're going to do is we're going to have 10 centimeters right here, and then we're going to have negative 10 centimeters right here. And at time equals 0, it's at its resting position, right? So right here, it's going to go to the right, and then it's going to go back to its original position, then it's going to go to the left, and then back to its original position, and it's just going to keep doing that. So if you notice right here, we've got a sine curve. So let's figure out some of our key information. So let's find the equation of the axis. So I'm going to take the min and the max and average them. So I end up getting 0 over 2, or just 0, okay? And that should make sense here, that 0 is going to be the equation of the axis. Then I'm going to find the amplitude, and hopefully you can realize that it's just 10 just by looking at it. But remember, we take the difference of the min and the max. So we end up getting 20 divided by 2, or just 10, okay? Then I want to find the k value. But to find the k value, I'm going to find the period. So the period is how long it takes to complete one full cycle. Well, if it completes 240 times in a minute, that means that in 60 seconds, it will complete 240 cycles. When I divide those two together, I can see that it takes 1/4 of a second to complete a cycle. So that means that the p-value is 0.25 seconds. So then to find k, I take 360 and divide it by the period. And when I do that, I get 1440. Okay? And then once I do that, I need to see if there's any type of horizontal phase shift. And because it started at the center right here, the halfway point at 0, there is no phase shift if I were to use sine. So d would be equal to 0. So I could write out that my equation is going to be y equals, the amplitude is 10 times the sine of the k value, which is 1440 x. And then there is no, the equation of the axis is just 0, so there's no need to write plus 0 at the end. So this could be my equation right here. Part B, how does the situation affect the domain and the range? Well, it's going to affect the domain and the range in the sense that the domain can only be, the domain is our time right here, so our time can only be positive values. So our domain is restricted to positive values because time needs to be positive. Time has to be greater than 0, okay, greater than or equal to 0. And then our range is dependent on the amplitudes, okay? It's always going to be dependent on the amplitude. And so here, our range would be y is an element of the reals such that y is between -10 and +10, okay? All right, lastly, if the wind speed decreases slightly such that the sway of the top of the pole is reduced by 20%, what is the new equation of the sinusoidal function? Assume that the period stays the same. So right here, instead of going left and right by 10 centimeters, it's going to decrease by 0.2 or 2 centimeters. So that means it's going to go down by 2 centimeters. So instead of going to 10 centimeters, it's going to 8 centimeters and -8 centimeters. So my graph would end up looking more like this. But it's the same idea, it's just our amplitude is now 8. Okay, so the new equation would be y equals 8 times the sine of 1440x. And that's it. Okay, we'll put degrees here so we know that we're talking about this in terms of degrees. And then that's all we need to know. All right, I hope you have a great day. Bye.